problem in here and see how we can work on this one, okay? So, let's read this problem first and see how we can work on this one, okay? Giovanni, all right, go ahead. Giovanni, go ahead. Given
A equals 5, B7, and C10, find the missing angles.
Find the missing angles, all right? So, first of all, let's consider this case, right? Step number 1. Katie, go ahead.
Draw and label triangle.
Draw and label the triangle there, right? Yeah. 5, 7, and 10, all right? So 5, 7, and 10, if we draw it in here, looks like this one. Okay, so 5, 1 is 7. So it's better if you have like a, straight edge to do this one here. 5, 7, and 10. Okay, so those are the 3 sides. We draw and label them. So again in here, it doesn't really matter which one is your small letter, right? So Coleman, can you give me what you want us to be your small a? Any of them will be fine, right? So there's no right or wrong answer for this one.
Let's go with the one closest to you. Small
One closest to me.
7.
7.
Seven. Yeah. Well, not the bottom, the top, closest to you.
Continue. Where's your B?
5.
5. Again, there's no right or wrong answer for this, right? And this one will be your small. Get it? Okay, so yeah. A, B, C, all right? Also, in an oblique triangle, already guys? Brian, we good? All right. So in here, we can also verify. This is what we call our triangle inequality. If you can still recall the triangle inequality, telling us that whatever your third side is, your C, it should be in between, it should be in between what? The sum of the other 2 legs and what? The difference of the other 2 legs. Alright? Okay, so here we go. You can put the absolute value, right? That the third side, in this case, your 10, the third side should be what? Less than the sum of those 2, which is what? 12, right? Okay. And also greater than, definitely, the difference of those 2, which is what? What's 7 minus 5?
2.
Are we good? Right? So that's basically our triangle inequality. That the third side should always be what? Less than the sum and greater than the difference of the what? The other 2 legs. Right? That's what we call our triangle inequality. Because otherwise, if it's more than 12 or less than 2, then in the first place, we don't have a triangle at all. Get it? Okay, because either it's going to be what? This one, right? Which is basically just a line segment, right? Or this one, right? Which is basically just that, right? Which is not a triangle at all, right? So for it to be a triangle, then the third side should be what? In between the sum and the difference of the other 2 legs. Okay? Other than that, then you can say, well, there's no triangle in the first place. Get it? Okay. Triangle inequality. Okay. Going back. Yes, we have drawn and labeled this one. Second step. Let's read this one, Kylene.
Is it SSS?
Thank you. Are the 3 sides given? Yes, it is, right? Now, we have to derive the formula for SSS. So here's what we're going to do. This is our law of cosines, but we want this, right? We want to solve for this angle. Solve for angle A. So how do we isolate that one from here? What do we do first? Get rid of these 2, right? So if we get rid of these 2, what do we do? Well, this is what I'm going to do, right? This entire expression, I'm going to put on the other end. And this entire expression, I'm going to put on this end, right? Which means it's going to give me the following, okay? Add 2bc cosine A on both sides. I'm going to have this 2bc cosine A, right? If I add 2bc cosine A on both sides. And in order to remove this and put it on the other side, subtract a squared on both sides as well, right? Minus a squared minus 8 squared. So with that, this will cancel out. That will cancel out, right? Hence, I have 2bc cosine A in here is equal to what? B squared plus C squared minus A squared, right?
Yo.
Get with what we did, guys. Once again, we want. Okay, here.
That flew over my head. Just
Okay, here we go. Here we go, guys. Because you want that big A, right? If you want to solve for that big A, you want it to be on the left side on its own, right? So if you want this to be on the left side on its own, then you have to put this entire expression on the other side. So how do you remove this? Add 2bc cosine A on both sides, okay? Similarly, you just want big A in here, but there's a small a in here. What you gonna do? To remove it, what do you do? Subtract a squared on both sides, okay? So that's basically what we did, right? Subtracting this will cancel it out and putting it in here. Subtracting this will cancel it out and putting it in here. Get it? Okay. Next one. We just want that. So how do we get rid of the 2bc? Division, right? So we're going to divide both sides by 2bc. So here it is. Over 2bc over 2bc. Get it? So that's going to cancel out for such. Okay, so in here we already just have this one left, right? That cosine of angle A is equal to what? B squared plus C squared minus A squared all over 2bc. Okay. And lastly, what do? We just want A. So how do you get rid of that cosine?
Cosine inverse.
Inverse. Very good, right? We're going to use the inverse trick in here finally. So I'm going to get the cosine inverse on the left. Also do the cosine inverse on the right, this entire thing. And those two, since they're inverses, they're gonna cancel each other out, okay? That's it. And that is your angle A. So your angle A measures how much? Cosine inverse of what? B squared plus C squared minus A squared all over 2bc. And it's actually interesting to point out in here is this, that whatever your angle, the angle that you're measuring is, or trying to find out is, that's always the last side in here, the one that is subtracted. Okay? Again, first and last. Whatever angle you're measuring, the last side should be the side opposite that. Are we good? Okay. So going back in here, what are we looking for? It says find the missing angles, right? So let's plug it in here. Where do you think in here is angle A? Where do you think in here is angle A, guys? Top, right, or left?
Right there.
Left.
Left.
Left. Okay, because that left is opposite small a, right? So that's correct. So this is your angle A. So in short, I'm going to use cosine law, SSS, for that angle A. So in here, angle A is equal to what? Cosine inverse, of what? So here, if this is big A, then that means in here, subtract is your small a. And what's your small a? 7. The other two in here will be the other two legs. What are those? 5 and 10, right? So just get 5 squared plus 10 squared, right? And whatever these two other legs are, you're going to put it in here. 2 times 5 and 10. Are we good? Right, guys? Right? So that's our angle A. But it says in here, find all the missing angles, right? So in short, what angle is this one on top?
C.
C, big C, right? So we're definitely interested to see how that one will look like. So just the same, that will be what? Cosine inverse of, okay, so that's big C. So that means in here, the last one in here should be the what? The last one in here should be the what?
C.
The C, right? Which is what? 10 squared, right? So whatever is opposite that angle should be the last in here subtracted. And the other two in here will be the other two legs, which is the what?
Be 7.
5 and 7, all right? Okay, or 7 and 5. It doesn't really matter, right? They're just the same anyway. And then in here, 2 times 5 times 7. Are we good, guys? Get it? What we did? Okay. Again, make sure that they are in degrees. Okay. Again, whatever angle you're looking for, then the last side in here should be the one opposite that, right? So if you're looking for angle C, then the last side in there will be opposite that, which is 10. And the first two will be the other two legs, okay? Let's plug it in here. What values did we get? Okay, so in your calculator, once again, always make sure that this is in degrees. Plug it in here, right? Where's cosine inverse? Right. Put in division bar. Okay, for angle A, we put the following, right? What's that again? 5 squared. Okay, plus, what's the, oops. Okay. Plus 10 squared minus, what's that? 7 squared. Okay. All over 2 times 5 times 10. Again, is it in degrees? Yes, it is in degrees. Are we good? 40, what's that? 40.5 degrees, okay? That is for what? Angle A. Put it in here, 40.5, okay? Approximately 40.5 degrees, okay? Okay, what about the other one? So basically, this is what I'm gonna do. I'm just gonna copy this one, reuse it for angle C, right? So it was our angle C in there. 5, 7, and then negative 10, right? So 5, I'm just gonna change this to 7, and I'm gonna change the other one to 10, right? And do the same on the other end in here, 2, 5, and 7, okay? Making sure that this is in degrees. Yes, it's still in degrees. How much did you get? 111.8 degrees, right? Okay. So in short, 112, right? So that's your angle. What's that? C, right? 5, 7 minus 10 all over 2, 5, 7. So in here, we can put in here what? Approximately 112, right? 112. Right? That is angle C. Now here's the deal. Well, if you have 2 angles already, you can get the third angle, right? So what do you think will be the third angle here? What do you do with those 2? 112 and 40.5 to get angle B.
Subtract.
Subtract from 180. Very good, right? So that's correct. What's that? 180 minus 112 minus 40.5. Okay, so put in here. 180 minus, what's that again? 112 minus, what's the other one? 40.5, right? So, yes, our angle B is equal to what's that again? 27.5. Thank you. 27.5 degrees. Again, knowing that, well, the sum of those 3 should be 180 anyways. So in here, well, you can also do this one in here if you want to. But again, if you already have the 2, might as well just add them up to 180 to get 180. Sum of interior angles of any triangle is always equal to 180 degrees. Are we good? Got it? Okay. So again, as a summary, how to solve for oblique triangles SSS case. Draw and label the triangle. Is it SSS? In short, are the 3 sides given? Law of cosines formula. So this is the law of cosines formula, right? If you're looking for A, then the last will be A. If you're looking for C, then the last will be C. If this is B, then the last will be B. And the other 2 will be the what? The other 2 legs, right? Are we good? Right? So again, there are 3 different iterations for this. Are we good? Right? So let me show you the other 2, right? What's the other 2? Again, if you're looking for B, what is this again? Cosine inverse of what? So if this is B, then the small b should be here, right? Minus b squared. And the other 2 should be here. What's that? A and C. Below will be the other 2, right? The first 2. Get it? Okay, so that's for angle A, that's for angle B. For C, what's that going to be again? Cosine inverse as well? Well, if that is big C, then that means in here will be the what?
C.
The small c. Squared it. And what's the other 2?
A and B.
A and B. Very good, right? So again, they're basically the same form, but just basically different iteration. The only thing that you would see in here consistent is what? Whatever the angle is, then the minus square, the last side, should always be the side opposite that angle that you're looking for, right? And the other 2 will be the other 2 legs. Are we good? Questions? So again, you have 3 different iterations for that. for cosine law. And definitely there are 3 different iterations for this as well, depending on what you're looking for. Is it small b you're looking for, small c you're looking for? It depends on what is given. Okay? Questions? All right. Thank you.